Okay then. Good morning, everyone. And this is
Good
lecture number.
morning, sir.
Good morning. This is lecture number 6 in ray optics, and today we are going to start refraction at curved surfaces. Up till now, what we had done was refraction at plane surfaces, whether it was a slab or it was a boundary between two mediums. The surface was plane, and we had seen that when a ray of light goes through a plane surface, which is a slab, the emergent ray and the incident ray, they are parallel to each other. The object, if I am watching from the other side, it gets shifted. Do we remember this?
Yes, sir.
Okay, in today's topic, what we are going to understand is refraction at curved surfaces. And again, when we talk about curved surfaces, we will have two types of curved surfaces. One will be a concave type curved surface, and the other may be a convex type curved surface. Do you understand the difference between concave and convex? We
Yes,
have
sir.
seen concave mirror, convex mirror. Similarly, we have concave and convex surfaces. So, without wasting any time, let us start with refraction on curved surfaces. And again, what we are going to do is going to start with your refraction at curved surfaces with a diagram. This diagram again is given in your sheet on, I think, page number 2020. So you can refer to that sheet and open page number 20, and you will see this sheet, refraction at transparent curved surface. Now this is a surface. Now what type of surface, first of all, would you call it? Will you call it a concave surface or you will call it a convex surface? What type of surface is this? Is this a concave surface or is this a concave surface? Remember, almost all of the times, 99.9% of the time, the object is always placed, if you can see, on the left side. So rays are always coming from the left side. O is the object. You can see this object, O,
Yes, sir.
and the image of this object is formed here. I is the image. We have taken a point object. O is the object and I is the image, and there is a curved surface. What will be the name of this curved surface? Whether it will be a concave surface or whether it will be a convex surface? Tell me.
Yes, sir. Convex, sir.
It will be a con.
Vex.
It
Convex.
will be a convex surface. Doesn't matter whether it's a concave surface or a convex surface. The idea remains same. Here they've explained all the terms that are coming in this section with this diagram of convex surface. Whether it's a concave surface, everything remains same. O is the object. Do we see this? O is the object and I is the
Yes,
image.
sir.
I'm
Yes, sir.
repeating myself. U, what is U? U is the distance of the object.
Of object.
Now the thing is from where? So let us first understand this concave surface. In this concave surface, we see something known as P, which is this point. This is known as the pole of the convex or concave surface. Do we understand this?
Yes, sir.
Again, this convex or concave surface will be part of a sphere. That sphere would have a center This C is known as the center of curvature of that surface. Do we see this C? And I hope you are marking it together with me in the sheet. This C is the concave surface or convex surface ka center of curvature. And do you see this R? This R is the radius of curvature, which is the distance of the center of curvature from the pole P of the surface. Do we understand this?
Yes, sir.
Okay. Now you can see U. U is the distance of the object from the pole P, and V is the distance of the image from the pole P. Are you all marking it out?
Yes, sir.
Okay. Now, here we have medium number 1 on this side, and here we have medium number 2 on the other side. Medium number 1, as you can see, has a refractive index mu1, which is marked here. So this is refractive index mu1. And for this, we have refractive index mu2, which is marked over here. So we have two surfaces. Incident ray are in medium number 1 and the refracted ray is in medium number 2. Do we see this?
Yes, sir.
Then we have this formula over here, which I am going to mark in red. This is the formula which we need to remember. Mu2, which is the refracted medium divided by V. Remember, this V is also in the refracted medium, which is marked by red. Mu2 by V. Mu2 is the refractive index of the second medium, and V is the distance of the image from the pole P in the second medium. Refraction is happening in the second medium. Mu1 is the incident medium ka refractive index, and U is the distance of the object in the first medium. Do we understand this?
Yes, sir.
That is equal to mu2 minus mu1, mu2 minus mu1 divided by r, where r is the radius of curvature. Do we understand this?
Yes, sir.
We'll have to remember this formula. Again, whatever formula we are applying here, the formula is in box. This formula has to be applied with proper sign convention. What is the sign convention? Well, the sign convention is same as what we had seen previously. We will go through this again. What was the sign convention? Can you tell me? The direction of ray of light is taken as? The direction of ray of light is taken as?
Fast.
Positive. Opposite direction is taken as negative. And all distances are always measured from where? All distances are always measured from the
Pole.
pole P of the mirror. Here it is pole P of the curved surface. So you'll have to measure all the distances from pole P. Pole P becomes your origin. So bacha, everything on the right side of P is becoming positive. Everything on the left side of P becomes negative. Everything top of P, above P becomes positive. Everything below P becomes negative. Do we understand this?
Yes, sir.
I'll give you a minute to note everything down in the sheet, or it's better if you can draw a diagram. That would be more better. Let's move ahead and see the convention for radius of curvature, and the convention is not different, it is same. Now, normally in case of mirrors or lenses, the object is normally placed on the left side. But in case of this refraction by curved surface, the object can very well be placed inside the curved surface as well. So the rays of light may be coming from the other side as well, from the right side as well. Now the sign conventions remain same. Everything in the direction of light rays is positive. Do we understand this? Now,
Yes,
if you
sir.
have this surface, now please remember, please remember, and don't get confused. If you have this surface, an object is placed here. If you have this surface and the object is placed here, if you have this surface and the object is placed here, light would be coming from here. The object is placed here. So this surface will behave as a convex surface. Yes or no?
Yes, sir.
And the center of curvature is here. The pole P is here. The distance will be measured in the direction of light ray, and therefore R for this convex surface will be taken as positive. Do we understand this?
Yes, sir.
Okay, that was case number 1. Now look at case number 2. Now the case number 2, what will you call the surface? Now you call the surface depending on where the object is placed. Here the object is placed somewhere here because light is coming from this side. Do we understand this?
Sir.
Now this surface for this particular case becomes a concave surface. Do we understand this?
Yes, sir.
Here again, the distance would be measured from the pole. The center of curvature is here. The distance would be measured in this direction, but light is coming from this direction, and therefore R in this case would be negative. Do we understand this? Can I have raised hand that we understand
Yes,
this?
sir.
Okay. Look at case number 3. Very nicely explained. Now, what do you call this surface? That is my first question. Tell me the answer. What do you call this surface?
Concave, sir.
This surface will be concave. Light is coming from this side. The object is placed somewhere here. So the inner side is exposed to the object, and therefore this surface becomes a concave surface, and all the distances are to be measured from the pole. Here the distance would be measured in this direction, but light is coming in this direction, and hence R becomes negative. Do we understand this?
Yes, sir.
Look at the fourth surface. What type of surface is the fourth surface? Light is coming from
Convex.
here. So object is placed somewhere here. So this outer side is exposed to the object, or our outer side is facing the object. This type of surface becomes a convex surface. Distances are measured from the pole. It will be measured in this direction. This direction is the direction of light rays, and hence R will be positive. Do we understand this?
Yes, sir.
Now, the thing worth noting here is you can always find out from the direction of light rays. But if you see, if the surface is looking convex, that was case number 1 and 2. If the surface was convex, value of R was coming as positive. Do we understand this?
Yes, sir.
But on the other hand, if the surface was concave, and I hope you have understood what is a concave surface, R was coming as negative. So this is what you need to remember. This is what you need to understand. Depending on the type of surface, depending on where the object is, the surface becomes concave or convex. If the surface behaves as concave, the value of R would be negative. If the surface behaves like a convex, depending on where the object is placed, the value of R automatically will come positive. I'll give you a minute to note these things down. Well, now is the time that we go back and have a look at whether this formula is also applicable for plane surfaces. Remember, this formula is valid, and why I am having this problem? Always have this problem. Okay, remember this formula is always valid for all surfaces where refraction is happening once. If it is happening more than once, we'll have to apply the formula 2 or 3 times. Whether the surfaces are convex, concave, or plane. Now we have already done refraction at plane surfaces, but we never encountered this formula. Is that so? No. We have encountered this formula in a different way. Now, if I apply this formula for, this is the original formula. I hope everyone can see this, yes or no?
Yes, sir.
For a plane surface, the radius of curvature is infinite. The radius of curvature is infinite. If the radius of curvature is infinite, whatever we have on the right hand side, mu2 minus mu1 divided by 0, r is very big, it is infinite. This thing becomes 0. So the formula becomes like this. Do we understand this?
Yes, sir.
All the formula reduces to this form: mu u by v is equal to mu1 by mu2. Instead of calling it as u and v, you can call it as real depth, and you can call it as apparent depth. So this is the formula that I gave you for real depth and apparent depth. I told you that apparent depth is real depth multiplied by mu2 by mu1. Do you remember it?
Yes, sir.
So I am not a magician. I just use this formula from curved surfaces, and I gave you the same formula for plane surfaces, and then I told you that this formula is applicable whether the ray is going from denser to rarer or the ray is coming from rarer to denser. Do we understand this? So we again arrive at our actual formula: d apparent divided by d real will be equal to mu2 divided by mu1. Do we understand this?
Yes, sir.
I'll give you a minute to note this thing down again. And hence we move ahead. Now this is a point which may not be discussed in the books, you might not have heard about them, but I've seen questions of this come. So please note it down and remember what is the focus. Now you must have heard about focus in lenses. You must have heard about focus in mirrors, but there are also focuses or foci defined for spherical surfaces. Now, whether it's a lens or it's a curved spherical surface where refraction is happening, two focus or two foci can be defined. The first one is known as the first focus, and the second one is known as
Second.
second focus. No prizes for guessing that one. Now, what is the difference between the first focus and the second focus? Now, if you go back to mirrors, where we had drawn the ray diagrams, and I told you a ray which is parallel to principal axis, after reflection will go through focus. Yes or no?
Yes, sir.
At the same time, I did the reverse of it, and I told you if a ray is passing through the focus, after reflection, it becomes parallel to the principal axis. Yes or no?
Yes, sir.
Yes or no?
Yes.
A ray of light which is parallel to principal axis will pass through focus. If I reverse it, a ray of light which is passing through focus will become parallel after reflection. Do we remember this?
Yes, sir.
Okay, that means there are two things that will happen. If it is passing through focus, it will become parallel, and that is the first focus. As you can see for a convex surface here, I have placed an object at the focus. Ray of light which is passing through this focus after refraction are becoming parallel to the principal axis. Do we see this?
Sir.
You'll have to draw this diagram, bacha. This focus is known as the first principal focus. First principal focus is the point on the axis where when an object is placed, the image is formed at infinity. That means ray of light are becoming parallel after refraction. Do we understand this?
Yes, sir.
Yes or no? No or yes?
Yes, sir.
Then we have the value of u as f1. You have the value of v as infinity. You apply these values in the formula that I have told you. U is negative, v is positive and infinite. Radius of curvature in this case is positive. When you apply this formula, you will get the value of the first focus. Now there are two ways of remembering it. Either you remember all this and apply the formula, or you remember this shortcut. This is the shortcut for the first principal focus, and this shortcut says that f1, the first principal focus, is minus mu1 r divided by mu2 minus mu1. Remember, this formula has to be applied with sign convention. Therefore, for a convex surface, radius of curvature is positive. This focal length will become positive or negative depending on mu2 minus mu1. It can be positive, it can be negative as well. Remember this formula, you can apply sign convention, you can put the value of mu1, you can put the value of mu2 and find out whether the first principal focus is positive or negative. The first principal focal length is positive or negative. Do we understand this? Can I have some raise hand that we understand this?
Yes, sir.
Yes, sir. No, sir. You'll have to draw the diagram, bacha, so that you understand this. First principal focus is that point where you should place an object. The image is formed at infinity. You may not remember it, but you'll have to remember this formula. I'll give you a minute to win it. Now is the time that we understand the second principal focus, and I will give you a second to tell me what would be the second principal focus be. The first principal focus is the point where if I place the object, the image is formed at infinity. Then what would be the second principal focus looking like? Can anyone tell me?
Object at infinity.
Object is at infinity. Where is the image formed? The image is formed at the second principal focus. You can see F2. Can you see F2? Rays of light are coming parallel. If they are parallel, that means they are coming from infinity. Object is at infinity. Where is the image formed? Yes, bacha, the image is formed at the second principal focus. Do we understand this?
Yes,
This
sir.
statement or this point is known as the second principal focus. Here u1 is minus infinity, v1 is f2. If you put the formula looks like this. Again, whether it be positive or it will be negative depends on two things. It depends on r1 or r2, whether it's positive or negative. It depends on the value of mu2 and mu1. So this is f2, which is second principal focus. I will also write f1 here so that you understand the difference between the two. For f1, we have minus mu1 r divided by mu2 by mu1. If you can remember one, and I always remember the first principal focus, you should be able to remember the second principal focus. In first principal focus, I have mu1 in the numerator. In the second principal focus, I have mu2 in the numerator. The only difference is in the first principal focus, I have a negative sign. Can you remember this now? I've told you my trick of remembering it. If you have your trick,
Yes, sir.
you can remember it by your trick. Remember, it's a class, it's not a boxing class. You should not box in the class. You should study in the class. And that is one thing that you must remember, that I'm not a martial art teacher. So let us concentrate on physics and not on boxing. I'll give you a minute to note things down. Remember, I am omnipotent
Okay.
and I am omnipresent. A very small thing to remember, the ratio of focal lengths, f1 by f2, we have seen the formula. If you divide f1 by f2, you will have this ratio minus mu1 by mu2. Do we understand this?
Yes, sir.
Please note it down. It's a very simple thing to note down. And then we can move on to some question and answer. I'll give you 5 seconds to note this down. Should not take more than 5 seconds. To note it down. I hope you have noted it down. Yes,
Completed,
sir or no, sir? Okay. Then comes a question that will make everything clear in our head. What type of questions are there and what you can expect in an examination hall. So here comes the question on your screens now. again taken from your sheet. An air bubble, chota sa air bubble is in glass. The refractive index of glass is 1.5, which is 3 by 2. Refractive index of water is 4 by 3. Remember that. An air bubble is present in glass. Mu is 1.5. Is situated at a distance of 3 centimeters from a spherical surface of diameter. Diameter is 10 centimeters, so radius of curvature becomes 5 centimeters. At what distance from the surface will the bubble appear if the surface is convex, which is case number 1? If the surface is concave, which is case number 2. I hope the question is clear to all. Is the question clear to all?
Yes, sir.
Normally, well done. Normally, in case of this refraction by spherical surface, you would be given a diagram because it depends on which side the object is placed. So normally you are given a diagram. You'll have to solve the question and you have 1 minute of time to do it. Do not waste your time in anything else. Anything else can wait. This question cannot. Okay, so what I'll do is, since this is the first question, I will tell you how to solve it, and I hope that you can do the second part of this question. Now, for the first part of this question, whether it's first part or is second part or is the third part or the fourth part, the formula remains same. And the formula is mu2 by v minus mu1 by u is equal to mu2 minus mu1 by r. Can I have some reason that we remember the formula? Mu1 is the medium in which the object is placed. That is glass. The refractive index is 1.5. Mu2 is the medium where the rays are going after refraction. That is air or vacuum. Value of mu2 is 1. This surface is behaving as a concave surface or a convex surface. I think it is behaving as a concave surface, the first one. So radius of curvature is -5. The value of u is -3. It is opposite to the direction of light rays. You just put the values in this formula and then you solve for the value of v, and you will get the value of v as -2.5. This is all maths, multiplication, division, addition, and subtraction. I can't help you with that. I hope you can do this. Yes or no? You can do this simple calculation. Yes, sir. You'll get the answer as -2.5, sir. -2.5 means it is on the left side of the pole. That means it will be inside the glass at a distance of 2.5 centimeter inside. Do we understand this? Yes or no? Can I have some raise hand that we understand this? Everyone. Okay. I have solved the first part, which was the surface like this. Now the surface has changed. Now I expect that you would be able to give me the answer of the second part. I'll wait. And I hope that this wait is worth it. A minute to win it. Well done. You have got the answer. This is a small victory for us. We must celebrate all our victories. Why my headphone is showing me all these different colors? This actually headphone belongs to my son and he makes his YouTube video. This is a gaming headphone. He makes his videos on that. So I used it because, you know, this is good. My voice is clear. I don't have to shout. Okay, so what we got to do here? So that's why it sometimes lights come up. It looks awkward on me. I'm not a gamer. Mu1 is 1.5. Mu2 is 1. I have told you that. R is +5 here. That is the only difference. You just put the values. U is -3. You put the values in the formula and you land up with -1.66 centimeters. It's very simple. You just put the values, plus, minus, divide, multiply, and you get your answers. Can I have raised hand that we understand this? I hope this is raising hand and this is not waking up from sleep, right? Great. Now we can just do a small exercise here. I mean, exercise does not mean that we do PTs. small exercise mean if what would have happened if the surface was plane. So instead of a concave or a convex surface, now can you give me the answer what would have happened if the surface was plane? Now if the surface is plane, this question becomes a question of real depth and apparent depth. Do we understand this? Where do I see the object? If I look from the other side, this is glass, something is in glass. I'm looking it from outside. Where do I see it? If the surface is plane, what is the answer? Now remember, now it is a question of real depth and apparent depth. Do we understand this, or it has gone too confusing? If it is a plane surface, that becomes a question of real depth and apparent depth. Can you tell me? Can you tell me the real depth is 3 centimeters? What is the apparent depth? You have a minute to win it. Well then, it's my humble duty to tell you the answer. What happens if the surface is plane? Same formula, 1 by V. V is unknown. U is minus 3. Mu2, sorry, mu1 is 1.5. Mu2 is 1. Instead of radius of curvature, I'll put it at infinity. So basically, mu1 by U becomes equal to mu2 by V. V becomes my apparent depth. U becomes my real depth. And the answer that you have is minus 2 centimeters. Do we understand this? Can I have some raise hand that we understand this? No one was able to solve this. That is not good because I was expecting that you would be able to solve this. Anyways, that's a disappointment from my side. But anyways, I hope you have been able to solve this. Let me see if I can find some question on this curved surface. And this is the question that I find that is coming in your screen, on your screens right away as soon as I cut it from this thing. Here it comes. Wow. A point object is placed in air at a distance of 40 centimeters from a concave refracting surface of refractive index 1.5, which is glass. If the radius of curvature of the surface is 20 centimeters, what is the position of the image? And I wait for your answers. This is question number 1, taken from I think section 3, and the page number is 52, my dear friends. Page number is 52, section 3, question number 1 is what we are looking at. So you can read it from the sheet if you don't want to look at the screen. You must be having very less screen time. I understand that. You can see it from the sheet and I'll wait for your answers. And you have a minute to win it as always. Great. So how do you solve it? We'll have to apply the formula. I hope everyone is looking at the screen. We have to apply the formula mu2 by V minus mu1 by U is equal to mu2 minus mu1 divided by R. You just put the values.
Sir,
What
90 sir board.
Yes, beta?
बोर्ड नहीं दिख रहा है सर.
बोर्ड नहीं दिख रहा है सर, तो क्या दिख रहा है?
पूरा ऊपर का है सर.
Something wrong. Just sometimes lafra happens. So I'll just stop it and I will try to share the screen again. Something wrong has happened and I was not able to comprehend it. I was busy solving the question. So I hope you see it now. Mu2 by V minus mu1 by U is equal to mu2 minus mu1 by R. We just have to put the values. I think the value of mu2 is 1.5, yes or no? 1.5 divided by V minus I think it is placed in air. So this is 1 divided by u. The value of u, I think, is minus 40. Just give me a minute. The battery of my this machine is going away. I will have to plug in, else things will go haywire. Okay, I think this is done. It is back online. Okay, so 1.5 by V minus 1 divided by minus 40 is equal to 1.5 minus 1 divided by minus 20. It is a concave surface. Yes or no? I don't remember the question correctly. I just writing whatever I remember from the question. I think let me check up with the question. U is minus 40 in air, radius of curvature concave. You just put the values, get the answer and stay happy. I think if you solve it, you are getting the answer as 20 centimeters minus 20. Yes or no? Yes, sir? I can't hear you, sir.
Yes, sir.
That's it. So that is what you do it. You just apply the formula. Have faith. Have faith. It's all about faith, bacha. Have faith that you can solve it. And I'm sure that you would be able to solve it. That brings us, I'll give you a minute while I am changing the screen to write the solution. And after a minute, we will begin with the next question. I hope everyone has written the solution. We begin with the next question, and this is the next question. Same page, same section, question number 2. And we'll not do more than this. Question number 2. Your time starts now. An object is placed at a distance of 10 centimeters in a medium of mu1, which is air, from the pole of a spherical refracting bounding medium of mu is equal to 1.5, which is glass. If the image is formed is virtual. Virtual means on the virtual side, on the refracting side. So this is what you need to understand. And it is a distance of 40 centimeter. What type of spherical surface it is? And your time starts now. Good luck. You might need it. But remember, don't depend on your luck, because your luck will evade you when you need it the most. Trust your hard work. It will never evade you. 1 minute to win it. So we start with the next topic, which is lens. And may I know what is a lens? The time I gave you was to understand and tell me what is a lens. So a lens, as you can see in your sheet, a lens is a piece of a transparent material with two refracting surfaces. So it must have, the first thing is two refracting surface. Do we understand this? Now, two refracting surface, even a glass slab has two refracting surfaces. The question is, do we call glass slab, a transparent glass slab, as a lens? Or you might have seen a prism. Is prism a lens? Well, that is what you need to understand. A lens is a piece of a transparent material with two refracting surfaces. A prism has maybe three. Transparent glass slab also has two surfaces at least where refraction happens. What differentiates a lens from a prism or a thin slab or a transparent slab is that at least one is curved. At least one of them is curved. So if you have any curved surface, one of them is curved, the other may be plane, the other may also be curved, then that thing becomes a lens. But remember, the refractive index of this material must be different than its surroundings. So if you have a glass lens placed in glass, it is not a lens anymore. It does not behave as a lens. It only behaves as plane surface. In fact, if the medium is same, it behaves as the medium itself. It does not behave as a lens. So at least it must be placed in a different medium, or at least one side If not both sides, one side should be different. Do we understand this, or it has gone above our heads? A lens is a piece of transparent material which has two refracting surfaces. At least one of them should be curved, and it must be placed in a medium which is different than its material. Do we understand this? Can I have some raise hand that we understand this? Don't understand this? Okay. Now we have two types of lenses. One is known as the converging lens, which converges. One is a diverging lens, which diverges. So in general, if I say a thin spherical lens with refractive index greater than of surroundings behaves as a convergent or a convex lens. It converges parallel rays. However, if the so basically they have two types of lenses, convergent and divergent. Converging lens is also known as convex lens. They converge light rays. Divergent lens diverge. And how do you understand whether a lens is converging or diverging, whether it is convex or convex? You can understand it by looking at the shape of the lens. If the central portion of the lens is thinner than the marginal, it will behave as divergent. So if you have a lens, and if I say this is my lens, if the central portion is thicker, if the central portion is thicker, if the central portion is thicker, it is convex. If the central portion is thinner, it is concave. Do we understand this?
Yes, sir.
Yes, sir. No, sir. A convex lens is always converging thicker in the middle. A concave lens is always diverging thinner in the middle. And that is what you need to note down. I will give you a minute to note it down. Do not spend your time in chit chat. Please note it down. Page number 22 on your sheet. And you have these different types of lenses that are drawn. This lens is known as biconvex. This is known as equiconvex. This is known as plano-convex, concavo-concave, convex, biconcave, equiconcave, plano-concave, and convexo-concave. In biconvex or equiconvex, both the surfaces are convex. In plano-convex, one is convex, other one is plane. In concavo-convex, one is concave, one is convex, but convex is more powerful than the concave one. In convex or concave, one is convex, one is concave, but concave is higher, is more powerful. Biconcave, both are concave. Equiconvex, both are concave, and they have the same radius of curvature. Do we understand this?
Yes, sir.
Then again, I'll give you a minute to note it down, and then we'll move on to the nomenclature or the terms that are going to come in the lenses part. If you understand these terms, well, the chapter is already over. I'll give you a minute to note this down. Well then, time to move ahead. The first term that you must understand is the optical center, or O, of the lens. As you can see, this point, you can call it somehow as the center of the lens. And if a ray of light passes through this point, it will go undeviated. It will just go straight. It actually does not go straight. It deviates a very little bit, but it just for some all practical purposes, to understand the meaning of this optical center, which is also may be known as the center point of the lens. It is a point where which the ray pass undeviated. It does not go undeviated. It is actually shifted a bit, laterally shifted, but the emergent ray and the incident ray, they are almost parallel. This point is known as the optical center of the lens. Do we understand this?
Yes, sir.
A minute to note it down, and then we'll move ahead. Do not waste time, beta. Then let's move ahead. The next thing that you must understand is the principal axis. What is the principal axis? It is a line passing through the optical center O that we have seen, and it is perpendicular to the lens. So that line becomes your principal axis. Then we have the principal focus. The actual name of this focus is principal focus. And as you have seen for spherical surface, we have two focus or two foci. Do we remember this?
Yes,
First
sir.
focus and second focus. Here also we have two focus. Here also we have two focus. First principal focus and second principal focus. Do we understand this?
Yes, sir.
First principal focus and second principal focus. This is first principal focus for a convex lens. This is the first principal focus for a concave lens. The definition is simple. If I place an object as the first principal focus, the rays after refraction becomes parallel or image is formed at infinity. Do we understand this? Do we understand this?
Yes, sir.
In case of convex lens, the rays are coming to the focus. In case of concave lens, the rays are directed towards the focus. Do we understand the difference between 1 and 2? Figure number 1 and figure number 2. Ray science will give me more confidence. You'll have to draw this diagram, bacha.
Yes, sir.
F1 for convex lens, F1 for concave lens. And if I go by sign convention, here all the distances are measured from O. Remember, here all the distances are measured from O. Remember, here all the distances are measured from O. So first principal focus F1 will be negative for convex lens, and the first principal focus F1 will be positive for a concave lens. Do we understand this?
Yes, sir.
You will have a minute to note it down. Remember to draw a diagram. Same question, same thing has been asked as question many times in the exam. So please don't be lazy. Draw the diagram and write the values. If you have understood the first principal focus, you must be able to understand what is the second principal focus. Who will tell me what is the second principal focus? You can see it in the diagrams. What is the second principal focus? For the first principal focus, when you place an object there, the image goes to infinity. For the second principal focus, object is at where?
Infinity.
Object is at infinity. When you have parallel rays coming from infinity, at some point they will converge in case of converging lens, or they will appear to diverge from a diverging lens. Do you understand the meaning what I'm saying?
Yes, sir.
Parallel rays of light, they will converge for a converging lens or diverge for a diverging lens from a point on the principal axis. That point, my dear friend, is known as F2, the second principal focus. Do we understand this?
Yes, sir.
Yes, sir, or no, sir?
Yes, sir.
Yes, sir. Then, sir, this F2, sir, and as you can see from the sign convention, sir, all distances are measured from the center O, sir. For F2, for a convex lens will be positive. F2 for a concave lens would be negative. Do we understand this? So for every lens, we have two focus or foci. We have two focal lengths. One is the first principal focus and first focal length. The other one is second principal focus and second focal length. Do we understand this?
Yes, sir.
And one more thing you have to understand, whenever someone talks about the focal length of a lens, remember this. We never ask which focal length, because whenever someone is talking about focal length of a lens, he is talking about which focal length? Every lens has two focal lengths. Every lens has two foci. When someone is talking about the focal length of a convex lens, which focal length is he referring to? He is referring to the second focus and the second focal length. And therefore, we say that the focal length of a convex lens is positive. It also has a negative focal length, but that is first principal focus. We do not talk about it. we normally always talk about the second principal focus and the second principal focal length. So second principal focal length or the focal length of a convex lens is negative. No, it's positive, and focal length of a concave lens is negative. Remember, we are talking about the second focus and the second focal length. Do we understand this? Do we understand this?
Yes, sir.
I'll give you a minute to note it down. Then we come to the next thing, focal length. Here they have defined the second focal length, but remember, focal length is just the distance of the focus from the optical center of the lens. Here the focal length that they have defined is the second focal length. Do we understand this? Because that is what normally we refer to. Remember, every lens has two focal lengths. The way they have defined it, they have defined it for the second principal focus. Aperture, remember, question comes on aperture. Aperture in reference to a lens, aperture means the effective diameter of the lens, the intensity or how intense or how sharp, not sharp, how big or how much energy that image has. The intensity depends on the amount of light which is passing. You must have heard about aperture of this lens. See, if I tell you, this is a phone that I have, right? It has 3 or 4 cameras. Every camera has a lens. Now, what determines the value of this camera or how good a photograph this camera can take depends on the aperture. F1.8, F1.9, F22, F standing for focal length. The bigger the camera, the better the camera. It has a bigger aperture. Bigger aperture means more light can come in. If more light can come in, better pictures it is going to take. That's why we have this what do I call them, cameras. We have different lenses in the camera. We have digital cameras. The bigger the size of the mirror, the bigger the size of the lens, the bigger the aperture, the costly is the lens, and it takes a lot of good images because a lot of light can come in, and that is what we refer to as the intensity of light. Intensity of light depends on the aperture square. Do we understand this? I'll give you a minute to note it down. Let us move ahead into rules of image formation, and in the next class we will be dealing with the ray diagrams, and I would ask you to see these ray diagrams before coming to the class. For the next class, what are the rules for image formation? It is very simple. It exactly same as what was there in mirrors. Number 1, a ray of light passing through the optical center goes undeviated. Do we understand this? Yes or no?
Yes, sir.
A ray of light which passes through the first focus will become parallel after refraction. Do we understand this?
Yes, sir.
A ray of light which is parallel to the principal axis will pass through the second focus. Yes or no?
Yes, sir.
These are the 3 rules which we'll be using to draw the ray diagrams. I'll give you a minute to note these things down. Well then, this finishes today's class. What we have done in today's class, we have gone pretty fast in today's class. We have done refraction by curved surfaces, by a single surface. We have seen the formula mu2 by v minus mu1 by u is equal to mu2 minus mu1 by r. We have seen that this formula is applicable for convex surface, concave surface, as well as plane surface. Do we understand this?
Yes, sir.
Then we have seen the sign convention. Sign convention remains same. The direction of light is taken as positive For the curved surface, all distances are measured from the pole P of the mirror. Then we have seen what is a lens. A lens consists of two refracting surfaces made up of a transparent material. At least one of them must be curved, otherwise it is not a lens, and it must not be placed in the same medium as the material itself. We have seen the important points about the lens. We have an optical center, rays passing through it will go undeviated. We have seen that there are two focus for refracting surface as well as for lens. First principal focus is the point where you place the object, image is formed at infinity. Second principal focus is the point where if the object is at infinity, the image is formed at the second principal focus. And we have seen the rules of image formation for the lenses. What you got to do in the next class is go through this part where we have image formation by convex lens, concave lens, and all that. We will have different positions, and depending on the positions we will have different types of image, real images and virtual images. Can you go through these things for me in the next class?
Yes, sir.
So if you can go through these things, we will have a pretty good time, and we can probably move faster in the next class. So for now, I take I'll say bye bye for today's class. It's over. Meet in the next class tomorrow. Take care and have a nice day. Stay safe. Bye bye.
Bye, sir.